I think question 55 gets my vote for the easiest question on the entire test. It was fairly surprising to me to see this one so late in the test. All you need to answer this question is the knowledge that the standard deviation of the sample mean, sometimes referred to as the standard error, typically written as sigma sub x bar, sigma kind of representing the standard deviation part of it, x bar representing the sample mean, standard deviation of the sample mean, is just equal to the standard deviation divided by the square root of the sample size. That's it. This comes from the central limit theorem and kind of makes sense if you think about it. But I'll save the intuition because I want to show you how easy this is to solve. The problem tells us that the standard deviation of the sampling distribution of the sample mean, so this thing, sigma sub x bar, is equal to 8 when our sample size is 30. In other words, 8 is equal to sigma divided by the square root of 30. What it asks is for the standard deviation of the sampling distribution of the sample mean, so the same thing, sigma sub x bar, when n is equal to 120. So if 8 is equal to sigma over root 30, what would you get if you took sigma and divided it by the square root of 120? Solve this first equation for sigma, plug that in down here, and you're done with the problem. From this first equation, I know that sigma is equal to 8 root 30. Plugging that into my second equation, my answer is 8 root 30 divided by the square root of 120. In other words, 8 times the square root of the quotient of 30 and 120. In other words, 8 times the square root of a quarter. In other words, 8 times a half. In other words, 4. Showing lots of work because there's nothing else to do in this problem. The answer to the question is just 4. 4 is option B. Done. How in the world is this question 55? I mean, I guess the idea is maybe not everybody knows this formula, in which case the problem's kind of impossible. But if you do know this formula, the problem's almost trivial. One last observation, because for some reason I have an issue with making this video like 1 minute long, is that we could have solved it, I guess, even quicker than this method if we thought more about the relative change in the sample size from 30 to 120 and how that's going to affect sigma sub x bar. Because the n is under the radical in the denominator, if we increase n by a factor of, I don't know, k maybe, we'll always be decreasing the standard error, sigma sub x bar, by a factor of the square root of k. So if it's really important to you to finish this problem in like 20 seconds, I guess you could kind of think that sigma sub x bar is equal to 8 when n is equal to 30. So when n is equal to 120, we've increased the sample size by a factor of 4. What that means is that the standard error, sigma sub x bar, will be decreased by a factor of the square root of 4, aka 2. So it'll go from 8 to 4. I feel like I'm just wasting time at this point, so I'm gonna stop this video.